Okay, hello everyone. So now we are doing the previous year questions of JEE Mains, and today we are doing complex number. So the first question we have is, let the complex number z is equal to x plus iy be such that 2z minus 3i divided by 2z plus I is purely imaginary. If x plus y square is equal to 0, then we have to find y to the power 4 plus y square minus y is equal to. So we have to find basically the value of y to the power 4 plus y square minus y. And the options given are 3 by 2, 2 by 3, 4 by 3 and 3 by 4. So anywhere we will get some z and the complex number value is actually given there, z is equal to x plus iy. So first thing we will do is, we will write this one, we will write 2z minus 3i divided by 2z plus I, and in the place of z we will replace by x plus iy. So first step we will do 2x plus iy minus 3i divided by 2x plus iy plus I. So this is the first step we will do. Now we will multiply, it will become 2x plus 2iy minus 3i divided by 2x plus 2iy plus I. Now we will separate the real part and the imaginary part. The real part we know, in this step the real part is 2x and the imaginary part are 2iy and minus 3i. So real part I am separating 2x and I am taking I common, so it will become I into 2y minus 3, correct, divided by what, 2x, and from both here I can take I common and this will become what, 2y plus 1. Now we have separated the real and the imaginary part, and one thing that you should be noticing here, that it is saying that it is a purely imaginary. So if something is purely imaginary, it means the real part of that is equal to 0. It means that the real part of 2z minus 3i divided by 2z plus I is equal to 0, right? Now this step we have to rationalize. So how we do the rationalization? We will change the plus sign into the minus sign and then multiply in numerator and denominator. So this will become 2x plus I 2y minus 3 divided by 2x plus I 2y minus 2y plus 1 and multiply by 2x plus I 2, and here it should be minus. So it will become 2y plus 1, and here also same thing, 2x minus I 2y plus 1. Okay. So till here it is correct, and now actually I have to, in the process of multiplication we will not multiply where the term is imaginary, because we have already seen that is the purely imaginary, that means real part we are equating to 0. So when we will multiply 2x into 2x, it will become 4x square. So this part I will be multiplying because I am getting something real. When this part will be multiplying with this, first part will multiply with this I part, it will become imaginary, so no need of multiplication. Then I 2y minus 3 multiplied by 2x will also give you the imaginary part, so no need of multiplication. When I will multiply I 2y minus 3 minus I into 2y plus 1, then we will get the real part. And what is the real part? Actually I into I will become I square, and the value of I square is minus 1, and here is the minus, so it will become plus. So it will become plus and then 2y minus 3 into 2y plus 1, and that will be equal to 0. And we will not be doing the multiplication of the denominator side. Reason is because when the denominator multiplication will go on the right hand side, it will automatically become 0, so no need of multiplication. Now next is what, 4x square, then you multiply this, 2y into 2y, it will become 4y square, this will become 2y, and this will become minus 3 into 2, 6y, and this will become minus 3 is equal to 0. Now 4x square and plus 4y square, and this will become how much, minus 4y and minus 3 is equal to 0. Now one more equation is there, given there, that is x plus y square is equal to 0. If x plus y square is equal to 0 means x can be written as minus of y square. So if x can be written as minus of y square, so I can write it as x is equal to minus y square whole square. Correct? X can be written as minus y square and here it is whole square plus 4y square minus 4y and minus 3 is equal to 0. Now minus y square to the power square is y to the power 4, so this will become y to the power 4 plus 4y square minus 4y minus 3, or better write minus 3 right hand side, it will become equal to 3. Now 4 I can take common from everywhere, it will become 4 y to the power 4 plus y square minus y is equal to 3. Now I can write y to the power 4 plus y square minus y is equal to what? 3 by 4. And that is what they are asking. They are asking what? Y to the power 4 plus y square minus y, this value, right? So it is coming as what? 3 by 4. So the answer is D. The D option is correct. I hope this is visible. I am giving you space so that you can take the screenshot if you want. Okay. Now I will move to the next question, and next question also belongs to the complex number only. And we will see the question, what the question says, and then we will move. I am erasing this side so that I can write the question. The solution is there so that you can see the solution. I am erasing only the question part. I am writing the next question, and this is also from the year 2023. Let A is equal to, here the theta belongs to 0 to pi, 0 to pi, and here it is given 1 plus 2i sin theta, 2i sin theta divided by 1 minus I sin theta is purely imaginary, is purely imaginary. Okay. So in this question they are saying that this part is purely imaginary and theta is belonging to what? 0 to 2 pi. 0 to 2 pi it is saying, and it is saying that purely imaginary. Then the sum of the element of A. Then we have to find then the sum of element of A. And okay, so the question says let A is equal to, and this set is actually theta belongs to 0 to 2 pi, and it is given in the numerator 1 plus 2i sin theta divided by 1 minus I sin theta, correct? Then it is a purely imaginary, again it is given purely imaginary part. So let's see how we will solve. Okay, so first step is they have given 1 plus 2i sin theta divided by 1 minus I sin theta. So first step we will do, we will rationalize it, and in the process of rationalization we know this sign will change, the here it is minus, so it will change into plus, and we will multiply in the numerator and the denominator. So it will, I will multiply 1 plus I sin theta divided by 1 plus I sin theta. Now easy multiplication we will do, 1 into 1 is directly 1, 1 plus I sin theta is I sin theta, and 2I sin theta into 1 is plus 2I sin theta, and 2I into I, this will become what? Sin square theta. So this I into I is what? Minus 1. So this will become minus 2 and I square is, so this will become minus 2 sin square theta, correct? Now again it is saying that the real part is what? It is not, it is given that it is a purely imaginary. So real part is equal to 0. So if something is equal to 0, same the denominator part, there is no requirement for multiplying the denominator part, and also you can remove this imaginary part and only equate the real part to 0. Real part we can equate to 0. So minus 1 minus 2 sin square theta is equal to 0, right? and that can be written as what? 2 sine square theta is equal to 1, or I can write sine square theta is equal to 1 by 2, or I can write sine theta is equal to plus minus 1 by root 2, correct? Plus minus 1 by root 2. Now you see, it will become sine theta plus minus 1 by root 2, and we have to see only for the values in between 0 to 2 pi. So it either it will become 1 by root 2 or minus 1 by root 2, and our limitation is from where to where? 0 to 2 pi. 0 to 2 pi we have to check. So we will do one. Sine, we know sine 45 is 1 by root 2. So first value it will come as pi by 4. Next it will come at 3 pi by 4. Next it will come at 5 pi by 4, and the last it will come at 7 pi by 4, right? These are the 4 values where the sin theta value will be 1 upon root 2 plus minus, correct? So now they are adding, asking the sum of the element, right? Sum of the element. So we have to add all these things. So let's add by taking the denominator as 4, LCM will be 4, and then pi plus 3 pi plus 5 pi plus 7 pi. So that will give 16 pi by 4, and 4 will cancel, 4 4s are 16. So the answer here will be 4 pi. So the answer here will be 4 pi. So that concludes your question number 2, and that was also from the year 2023. Now we'll move to the question number 3rd, and I am writing the question number 3rd. Question number 3rd says, for two non-zero complex number, non-zero complex number Z1 and Z2, Z1 and Z2, it is Z2 here, Z1 and Z2, if real part of Z1 into Z2 is equal to 0 and real part of Z1 plus Z2, real part of Z1 plus Z2 is equal to 0. Okay, so real part of Z1 into Z2 is also 0 and the real part of Z1 plus Z2 is also 0. Then which of the following are possible? Then which of the following are possible? Which of the following are possible, right? So options are: imaginary part of Z1 is greater than 0, imaginary part of Z1 is greater than 0, imaginary part of Z2 is greater than, and imaginary part of Z2 is greater than 0. Second options are: imaginary part of Z1 is less than 0, imaginary part of Z1 is less than 0, and imaginary part of Z2 is greater than 0. Imaginary part of Z2 is greater than 0. Third option is imaginary part of Z1, imaginary part of Z1 is greater than 0 and imaginary part of Z2 is less than 0, and imaginary part of Z2 is less than 0, and the last option we have is imaginary part of Z1 is less than 0, imaginary part of Z1 is less than 0, and imaginary part of Z2 is also less than 0, right? So we have to see which are the options which are correct, and now they have given the option set as B and D, A and B, B and C, A and C, right? So we will see by that. I am not writing those options in pair, so I am just writing here. Now I am erasing this part solution, and let's see what does this question says. Okay, so they have given Z1 and Z2 as two complex number, and the real part of Z1 and Z2, when we are multiplying, it is equating to what? 0, and here the real part of Z1 and Z1 plus Z2 is equating to 0. So whenever we get Z1 something, we can take it as x1 plus iy1, correct? That becomes your first complex number. Then Z2 can be given as x2 plus iy2. Now the real part of Z1 into, so Z1 and Z2 if I am multiplying, let's suppose x1 plus iy1 multiplied by x2 plus iy2, and I am equating it to 0, so only the real part. So real part, when I will multiply this x1 into x2, it will become what? x1 x2. When I will multiply x1 into iy2, it is a complex, so I will not, it is a imaginary part, no, x1 into iy2, so it will become imaginary part, so let's forget. And then this also will become what? iy1 into x2, this will become what? The imaginary part. So that also I can, but when I will multiply this I into y1 into, this will become what? I into I square, that will become minus 1, and minus 1 into minus y, and that is the, now become the real part. So that can be written as x1 into x2 is equal to y1 into y2, and that can, I am assuming it as equation number 1, right? Now the next condition, real part of Z1 plus Z2 is what? Equal to, and there here it is 0, right? Real part of Z1 plus Z2 is 0. So real part of Z1 plus Z2 is what? Real part of Z1 plus Z2 is what? X1 plus X2 is equal to what? 0. X1 plus X2 is equal to 0. So from here I can get X1 is equal to minus X2. That can become equation number 2. Now if I put the value of X1 equal to minus X2 in equation first, put x1 equal to minus x2 in equation first. So what it will become? It will become what? Minus x2 into x2 is equal to y1 plus y1 into y2, right? And now this can also be written as y1 into y2 is equal to minus x2 whole square, right? Now you see, if the value of x2 is negative, then the negative square will become positive, and this will make it negative. So anyhow this side is going to be negative. So if I want this to be equal to y1 into y2, the only thing is either the y1 should be negative or else the y2 should be negative, because if y1 and y2 both are positive, then the product of this will give you the positive result. But if, and again also one more case, if y1 and y2 are negative, in that case also negative into negative will give you positive. But here on the right hand side, it will, all the cases will be negative only. So the only case on the left hand side when this will become negative, either of one should be what? Negative. So either the imaginary part of Z1 is less than 0, or the imaginary part of Z2 is less than 0. So we will see the option. We'll see here imaginary part of Z1 is less than 0 and imaginary part of Z2 is greater than 0. So it is alternating condition, so that will be valid. Again next you see, imaginary part of Z1 is less than 0 and imaginary part of 2 is less than 0. That is also valid, because one of them is greater than 0 and one of them is less than 0. Then we can get the multiplication sign, and here we will get the negative sign, correct? So I think that is that. By that question we can conclude the session today. Tomorrow we will meet with some other questions. Thank you for joining.